Yes, yes, sorry. I'm just getting used to this new, yeah. So let us see patterns. Do you guys see when I write? Yeah, okay. So patterns in decimal expansion. Yeah. Let's just see some, I mean, other I should say patterns in patterns, right? Maybe, okay. But if we look at this, if you look at the number half, then the pattern does not start from the beginning, okay? If you look at the number 1/3, then we all know that this is like this, okay? So this starts from beginning, right? And then 1/4, this will again not qualify as starting from the beginning if we have to be precise, right? 1/5 also. I'm just getting used to this new thing now. This speed is different and everything. So this is no. So this is 0.2. Okay. What about 1/6? Point 166. Yeah. So I can see the pattern does not start from the beginning, right? And then 1/7, it starts from the beginning. So well, I don't know. What is it? 1/4. And then again, good. Yeah. So this again starts from the beginning. So can you guess anything by looking at the examples so far? 1/8 does not start from the beginning, we know. And then look at 1/9. What is 1/9? Is it 0.111? Yeah. Okay. Start from the beginning. So any guesses about what fractions, for what fractions the pattern will start from the beginning? So I haven't done anything. I've just written some things here which everybody knows. But 9 is not prime, right? 9 is not prime. No, because 1/6, you see, yeah. So what gives you this initial non-patternness? Okay, so I will not answer the question, but let's do some further this further thing. These are the things that will motivate one to study. The actual answers to these will take some number theory, okay? But we will be able to see a few things, I hope. And this is certainly, I think it's interesting. So you guys will tell me. Let us see in a slightly abstract way, okay? So what leads, abstract in the sense it will be cleaner to see see what's happening. What leads to initial non-patternness? Because we know that eventually everything has a pattern. Is that right? After some point, everything has a pattern. You cannot, there is no escape. But initially in some numbers, there is no pattern. So let's say that you have a number. Let's just take a number of the form 1 by only for simplicity. Let's say if you have 1 by n, and initially there is no pattern in the sense that, let's say that initially you get some a, b. So these a, b's, just think of them as digits. You can put any digit there if you want. And let's say after that there is c, d, c, d, c, d pattern. Then from here, what can you say about the number n? Yeah. Is there anything we can say about the number n? Just from here. Um, no, no. Why? No, that is not true. Let's assume they are distinct. It doesn't matter, but let's assume they are distinct. And you can see that 1 by 4 has this feature, but n4 is not odd. Yeah. For 1 by 4, there is 2, 5, and then 0, 0, 0. Right. I mean, you can say this is 0, 0. So, but yeah, I understand. So there are, I think, I don't know the answer. Okay. But there are two things that one can try. One is there is a, based on manipulation that you guys would have seen, converting from fractions to decimals and from decimals to fractions. If you have not seen, then you'll see it now. One way is slight manipulation technique. And that is, let's say, something like this, I think. If we would like to use this initial non-patternness, I will multiply both sides by 100. Okay. And then we get this. Right. I multiply both sides by 100 and I get this. Now, how can I use this? So I can take this 100 by n, and let's say I multiply by another 100 just for the CD. So let's say I make it 10 to the power 4 by n. And this is, so this will be what? This will be CD dot CD, CD, CD. You guys agree? Haha, so there was an AB, I forgot. Sorry. Yeah. I just took AB as 0, 0, which is enough to explain, but it's wrong to say, yeah, in the side. Right. So initially I have AB, CD, CD. Okay. And then again, when you do, and you will see why I'm doing this. It's not some magic. It's not some very tricky thing. Because now if I subtract things, simplify. And this is a technique used to from a infinite decimal expansion to get to a fraction, if there is a fraction. Yeah, this is a technique. Then you subtract things, simplify. So what do you get? Let's subtract the second from the first. You get 10 to the power 4 minus 10 square by n is equal to what? An integer. Okay, that is a good thing. That's a good thing, right? Now, what can you guys say about n? Is there anything that we can say about n? I don't know if you can say or not. So there's 10 square minus 1. No, but n may divide 10 square also. Yeah, so that's the thing. I mean, we cannot really say, we cannot really say, all we can say is that this is an integer. And yeah, but let's maybe we can try to 1 minute. Am I doing something incorrect here? Yeah, so let me just write this fully. So we have 10 square times 10 square minus 1 by n, and this is equal to this ABCD minus AB. I'm just a little worried about this thing, but it seems correct. We want to be able to say something surely about n, but we are not able to say that so far. Yes, so there are certainly two cases. No, but you see, it could be a mixture also. Yeah, it could be a mixture also. So we cannot really say. So n could be like 10, take 10 from this factor, and it would take 9 from the other factor. So we cannot really say that way. But if you look at this type of number, what is this type of number? So this is like 10 to the power 4 minus 1 times a, because you know, if you just write not 10 to the power 4, you write it as 10 to the power 3 times a. So just the decimal meaning of that number, right? What does it mean? This is what it means. 10 square times b plus this. But then you're subtracting ab. So when you're subtracting AB, it means 10A, right? This A has the value 10A, right? 10A plus B. So it becomes, yeah, then it's hard to write it in that way. Okay, so this is not really telling us anything. I mean, it's kind of telling us in one sense that N could be a multiple of, you know, N could have a factor of 2 or 5. You see? N could have a factor of 2 or 5. That is what I'm trying to say. Okay, and that is where we are trying to tend to, that the denominator will have some 5s or 2s. Okay, and you can see in the examples we have done, everything that has a 5 or a 2 has this property, that there is an initial non-patternness. Okay, and everything that does not have a 5 or a 2, that doesn't have any initial patternness. Sorry, initial non-patternness, if the pattern starts from the beginning. It may be a long pattern, but it starts from the beginning. Okay, so that is what it seems like, but this analysis is not telling us that directly. But yeah, so maybe, but the point is that there is an initial non-patternness in 1/6, right? And 1/6 has a 2 in it, right? So it goes with our guess, right? Everything that has a 2 or a 5 in it, there is an initial non-patternness. Like this one is the initial non-patternness, right? Okay, so that is what I'm trying to say. But let's see if we can say something more precisely. Let us take a number like this. Let's say that if I give you something like 1 by, let's say 20, 20 you would say directly. Let's say that 1 by 15 times n, some number. It has a 5 in it. Okay, we don't know the rest of the number too well, but we know that it has a 5 in it. Now you see, because it has a 5 in it, it becomes like this, right? And now I want to see if I can use this to say something. So maybe I can do 2 by 10 times 1 by 3n, right? And this, what does this become? this becomes 0.2, right? Times 3n. But then can we use this to say something? So I wanted to show that from this thing directly, if one can get some does anybody see how we can say that in the expansion, in the decimal expansion, there will be that initial, there will be some initial non-patternness. It is not easily clear. Yeah, without some theory, it is not initially clear. Yeah, that's the problem. Okay, so let's try a different approach. Okay, we're just trying a different approach is well, what does this 0.a mean? This will also answer the question last time that we were trying to understand the meaning of decimals. That this meaning of this decimal is that this is a by 10, right? Plus b by 10 square. So are you guys aware of this? Like, this is what decimals mean. When it's on the left of the decimal, then it's, it's powers of 10. And when you go to the right, it's also powers of 10, but it's negative powers of 10, or you can say it's 1 by. Okay. Yeah, so this is what it is. And now we can further go. So I'm just seeing if we can say that, if we can prove this fact that having this 2s and 5s in the beginning creates this non-patternness. We kind of got some hint from the last analysis, but we didn't get anything clearly. Just a second. Yeah. We have this, then what can we do? Is this any different from the last time? So a by 10, b by 10 square. So just thinking. Now it's difficult to say, right? Yeah, it seems difficult to say anything clearly from here. So then I suppose it's hard to say. So yeah, don't just let's spend 5 minutes more, then we'll come back. We'll go to the topic, okay? So it seems hard to say because usually the way we do it is using modular arithmetic. That makes a lot of things easy, but just thinking, just give me 2 minutes. So we are not able to attack it from this direction, right? That if there is an initial non-patternness, then we want to say that the number has a 2 or a 5, but we are not able to say it. Let's attack it from the different direction. That is, if there is no non-patternness, and let's see if we can say something from there, right? That's the next approach, right? Because we are not, successful in this from this direction. So I'll write it in English first. So we are analyzing fractions with no non-patternness. Is there a better word? In decimal expansion. Okay, let's not think about a better word. Let's use it to yeah. So what I'm saying is that let's say that you take a number like 1 by n, and there is a pattern right from the beginning. The length of the pattern is not important now. Okay, that also yeah, but later. Let's say that length 3 pattern, that exact length doesn't matter. What do we want to show? We want to show that n doesn't have a 2 or a 5. Right, like if n has a 2 or a 5, then we want to say that there is a non-patternness, but then that's the same thing as showing this, that if there is no non-patterness, like if the pattern starts right from the beginning, we want to maybe show that n doesn't have a 2 or a 5. Let's see if we can do that at least. So how do we go? So we'll try to just follow the same trick, you can say, and just multiply by 10 cube and subtract it from the number, right? Just same things continue. That's the point of having, that's the meaning of having a recurring pattern. Then you subtract this, right? So what does it mean? It means that n divides 10 cube minus 1. I mean, because the difference is an integer. So are we able to say something now? Yeah, yes. Otherwise it will not be an integer. Perfect. Okay, right. So that's the thing. We have got something, okay, after some analysis. So this implies that GCD of, I'm just writing it in this way, GCD of 10 and n is 1. See, this is how you have to do maths. You won't get things in one go, okay? Usually, it's good if you get, but yeah. But usually it's not possible to get it directly. Yeah. So no pattern initially means this. Yeah, means that n cannot have a 2 or a 5. Okay. Can you guys say something about the length of the pattern from here? That is a little tricky, but any comments on the length of the pattern? This is a little tricky question, but think. It has to do with this 3 and n dividing 10 to the power 3 minus 1. Yeah. See, if the pattern length was L, if the pattern length was, let's say, 12, right? Then n should have divided 10 to the power 12 minus 1. Is it right? Okay, so well, that is one way. But if let's say that if n divides, if let me write it like this, if n, so if this is an integer, okay, if this is an integer, then can we say that the length of the pattern is L or less than L? Can we say that? So, I mean, certainly if the pattern length was 10, then n should divide 10 to the power 2 10 minus 1 and so on, right? But if I take the smallest L such that 10 to the n divides 10 to the power L minus 1, does it mean that the length of the pattern is L? Yeah? Does it mean that length of pattern is L? You will see that the answer is yes, but it's a little tricky. If this is the smallest L, so basically the smallest power that you need to take, that you need to raise 10 to get this 10 to the power L minus 1, this is the length of the pattern. Okay. This I'm just telling you as a fact, which you can kind of partially see. To see it fully, it's a little tricky, but you can partially see. Yeah. In other words, length of the pattern, and we're doing with numbers like 1 by n. If you take numbers by m by n, there will be not much difference if m is coprime to n, because that will not going to destroy any pattern or change any pattern. But let's just focus on this thing only. See, length of the pattern is L. That is the same thing as smallest L in 1, 10, 10 square, right? Which leaves a remainder 1 when divided by n. Yeah, the smallest n, or the smallest L, that leaves remainder 1 when divided by n. I mean, this is the same thing as saying that n divides 10 to the power L minus 1. Right? And n divides 10 to the power L minus 1 is the same thing as saying that 10 to the power L leaves a remainder of 1 when divided by n. No, I do not agree with you. Why? Why do you think so? Mhm. Yes, yes, but that doesn't mean that n has to divide that 9, right? N could divide the other factors. N divides this, means that this upper thing can have many, many factors. N has to divide some of those factors. Right. I mean, every factor in n has to be in above, but n doesn't have the responsibility to have every factor that is there in above. Right. That's meaning of dividing. Eh? So n can have many. I mean, the numerator could have all sorts of factors. We don't know. Okay. So this is the thing. So what have we seen so far? We have seen that, look, if there is no pattern, sorry, if there is a pattern right from the beginning, if there is no pattern, that's a very dangerous place, irrationals. Yeah, if there is a pattern right from the beginning, then it means that n is co-prime to 10. Okay, and the length of the pattern is the smallest power, such that n divides, n leaves a remainder of 10 to the power that leaves a remainder of 1 when divided by n. Now we want to say the converse, that is, if the GCD is 1, now we want to say that if the GCD of 10 and n is 1, then there is no non-patternness in the beginning, meaning that there is a pattern right from the start. This is the other direction, right? We have seen that if there is a pattern right from the start, then n doesn't have anything to do with 10 as factors. 2 doesn't have 2, doesn't have 5. It's co-prime to 5 and 2. Now the reverse we need to show, right? If it is co-prime, then then this happens. Then there is no non-patternness, right? That is a converse. So are you guys? Do you guys? That's a converse. Okay, but we will not do it. Okay, it can be done, but it again needs more things. So let's not go into. Okay. So just take a minute and see if you have any questions. I'll just come. Okay, just go over everything. Think in your head and think. Okay, then ask me questions. Okay. So yeah, please ask questions, because there are a lot of questions here actually lying around. Okay, then if there are no questions, then let me ask. Okay. Well, there is one main question here, is that why should there be a L which leaves the remainder 1? Right? I mean, for any number n, why should there be a power of 10 which leaves a remainder 1 when divided by n. Right. Do you guys see? I mean, that's the first question, right? Why should there even be such a thing? So what do you guys think? Do we have a proof of that? Yeah, you see, we need to prove this, right? This is a separate thing in the sense, yeah. So we will prove this using Pigeonhole principle. Okay, so that will be maybe a good start to Pigeonhole principle. And the rest of the remaining things can be done from here, but let's not go technical into that because that will be different reasonings. So then our first problem, so maybe I